In the last video, we have made a 12 volt regulated power supply. So it was like an assignment that you could add another power supply ahead of 7812 or like 9 volt power supply or 5 volt power supply. So I'll just show a simpler way that how you can do that if you have not figured it out yet. We can use the left mouse button to select the part of a circuit. So I have selected the part of a circuit which is the regulator part. I will just click the right mouse button and copy this part to clipboard, then deselect and again click on the right mouse button and paste from clipboard. So the part of the circuit that I had copied, we can place it however we like. Just check once, just cross check with the reference circuit. So over here the value of the electrolytic capacitor is less, it is 10 microfarad. So let's change the value by editing the label to 10 microfarad. Click on OK. Now we have the ceramic capacitors. The probe that is copied can cause problems later, so we'll just remove it by double right click on the mouse and put another probe over here. Now I'll just align the circuit with the previous one. Now the output of the 12 volt regulator goes to the regulator circuit of 5 volts. I will have to change the regulator IC, of course. So here we have selected 7805. I'll just connect everything, pin 1, pin 3 and pin 2 to the ground. So everything is connected. Just click the probe over here and now we can get the output at V0 of U2. So here we have the U1 V out and the U2 V out. So we'll just simulate and see. So here we have the 12 volts regulated output and here we have the 5 volts regulated output. So we have completed the regulator circuit and also we have learned some basic shortcuts and how we can make the circuit more presentable. So now we'll start with the dual regulated power supply. So I'll just shift the circuit a bit upside. I will have to first stop the simulation, then I can select and move it a bit to the top. Now I will remove this reference model and select another image. So go to file, import image, and then all files. Then we have your dual power supply image. We'll just open it, place it at the bottom. So here we have the dual power supply. Let's see the similarities and the changes that have occurred in this circuit than the previous one. So first of all, we can see the transformer type has changed. Instead of a regular transformer, over here we have to use a center tap transformer. So the center tapping acts as the ground. The upper part acts as the output for the positive side, like this one, and the lower part, which was grounded initially in this circuit, it will act as the negative power supply. So we'll start making plus 5 volts and minus 5 volts power supply. I'll just reduce the size over here, and now we almost have every component, just this transformer is a different one. So we'll go to pick the transformer. Here we have the different types of transformers. This is the center tap secondary winding transformer. Just select it and click on OK. Now we'll start making the circuit again, so we can revise the parts that were missed in the earlier circuit, if any. So let's start with V sign. Put this over here. Then I think we don't need the voltmeter again because we know now, right, like what the editing should be done in the properties of this and this. So we'll just avoid using voltmeters over here. We'll put the transformer, center tap transformer, connect it to the voltage source. Now we'll make the bridge. Then connect the ends just like we had done it previously. Then give the input similar way. Here goes one, here goes the another one. So after this is done, for the output we'll first place the electrolytic capacitor. Here, rotate it. I place one capacitor above and one capacitor a bit below, so that we can understand the different uh, means the different regulators. So this is done. Then the other capacitor, the ceramic ones. Then after that we will connect the output, I mean the output of the transformer to this capacitor. So this one will go over here, and the lower part, as you can see, will be connected to the ground. So we'll take this ground and just connect it like this. So in here, in the where we are going to get the positive voltage regulator, the positive side is given to the output of the bridge, and the negative side of the capacitor is given to the ground. Inversely, we have to do that to the negative regulator, negative voltage regulator. Like the positive side will be connected to the ground, as you can see, and the negative side will be connected over here to the bridge. So here we connect it and connect it further to the next capacitor. Then the grounding. Okay, so in the last video we had forgot to initially we had forgot to put this ground symbol, so I would better put it now itself, so just not to forget it later. So just connect the ground. Now we can proceed with the other components. Like now for the positive regulator we can use 7805. So this is the input, the ground, and the output will be given to the other capacitor. Now after this is done, for negative regulated power supply we need the 79 series. So I will just go to pick components and get the 7905 IC. So this is the 7905 IC. Just click on OK. Then put it like this so that the ground pin goes upwards. So you can see the V in part should be over here and the V out part should be on this side, on the right side. So what I will do is I will right click on the component. I will do the X mirror option. So you can see the V in part comes to the input side like this way. The ground will be connected here and the output will be connected to our capacitor like this. So once these connections are done, we'll select the probe option to check the voltage, one over here and one over here. Now after all the components are done connecting with the circuit, what we'll do is we'll change the values of the components. So the electrolytic capacitors are 2200 microfarad, so we'll edit the label to 2200. So you must be thinking like why I'm making the regulators as my first assignment for you, because in most of the circuits, may it be microcontrollers or any other circuits, you require regulators on the input side. Most of the times, almost 80% of the circuits require regulators to be made for the active components that are present on the board. So it's better that you learn the circuits before anything else. So we have changed the values of the capacitors. Now we have to determine the AC input and the transformer. So we'll first right click on AC input, edit properties, and change it to 325 as I had shown in the earlier video. Like why 325 is required as amplitude and 50 hertz. So after this is done, we'll right click on the transformer and give the 375 millihenry and 1 millihenry over here. Click on OK. Now after this is done, everything looks good. Just let's simulate. Now while simulating, both the circuits will get simulated as they are in the schematic screen. So there the simulation has started, and you can see we have got the 5 volts output over here and the minus 5 volts output over here. So we have created a dual regulated power supply. If you want to check the input with respect to input, you can put a probe over here too to check what the input is. Click on simulate and see. The input is around 12 volts AC, which is rotating. As you can see, is a center tap transformer, but the output is regulated on both the sides. This is plus 5 volts and this is minus 5 volts. So that's what the regulators are all about. In the next videos, we'll be learning to make PCBs of these circuits itself. So we'll wait until then. Practice various other schematics like using timer ICs or other basic circuits like clippers and clampers. If you have any doubts, you can mention them in the comment section and I will get back to you. So I hope you have learned something new, and I have at least tried to plant a seed of curiosity in your brains. So you will learn and you will practice and you will find doubts, of course, but you will learn again. So that's what all about. Stay tuned for the PCB layouts.